Hello friends, welcome back to my YouTube channel Learner AK. Friends, today we learn about AFM, Atomic Force Microscopy. Let's learn friends. AFM is a type of scanning probe microscopy with demonstrated resolution on the order of fractions of a nanometer, more than 1000 times later than the optical diffraction limit. The information is gathered by feeling or touching the surface with a mechanical probe. Piezoelectric elements that facilitate tiny but accurate and precise movements on command enable precise scanning. Let's know friends principle. The AFM consists of a cantilever with a sharp tip at its end that is used to scan the specimen surface. The cantilever is typically silicon or silicon nitrate with a tip radius of curvature on the order of nanometers. When the tip is brought into proximity of a sample, surface forces between the tip and the sample lead to a deflection of the cantilever according to Hooke's law. Depending on the situations, forces that are measured in AFM include mechanical contract forces, that is van der Waals forces, capillary forces, chemical bonding, electrostatic forces, magnetic forces, etc. Along with the force, additional quantities may commonly be measured through the use of a specialized type of probe. You can see figure friends. This is the figure you can see in full screen. Photodiode, laser, cantilever, and tip. This is the figure A and figure B friends. In figure, first a small spring like cantilever, second support, third a huge electric element, four sharp tip, five detector, and six sample, seven XYZ drive, that is X0, Y, Z, eight sample stage. The small spring like cantilever one is carried by the support two. Optionally, a piezoelectric element third oscillates the cantilever one. The sharp tip 4 is fixed to the free end of the cantilever one. The detector 5 records the deflection and motion of the cantilever one. The sample 6 is mounted on the sample stage 8. An XYZ drive 7 permits to place the sample 6 and the sample stage XYZ direction with respect to the apex 4. Although the above figure shows the drive attached to the sample, the drive also can be attached to the tip, or independent drives can be attached to both, since it is the relative displacement of the sample and tip that needs to be controlled. Let's know working friends. According to the configuration described above, the interaction between tip and sample, which can be an atomic scale phenomenon, is transduced into changes of the motion of the cantilever, which is a micro scale phenomenon. Several different aspects of the cantilever motion can be used to quantitate the interactions between the tip and sample, most commonly the value of the deflection, the amplitude of an oscillations of the cantilever, or the shift in resonance frequency of the cantilevers. The detector 5 of AFM measures the deflection of the cantilever and converts it into an electrical signal. The intensity of the signal will be proportional to the displacement of the cantilever. AFM operation is usually described as on the three modes according to the nature of the tip motion. Contact mode, also called a static mode, tapping mode, and vibrating mode. Let's know about applications. This is the first application. AFM has been applied in a wide range of disciplines of the natural science, molecular engineering, polymer chemistry, surface chemistry, etc. And then second, it is used in the identification of atoms at a surface. Third, in molecular biology, it can be used to study the structure and mechanical properties of protein complexes and assemblies. And then for in cellular biology, it can be used to study attempt to distinguish cancer cells and normal cells based on hardness of cells. And then five friends, it can also be to study how cells regulate the shape of cell membrane of or wall. Thank you friends. We made in next video.